It all starts with a glucose molecule. An ATP invests a phosphate group and it gets attached to the glucose. And then one bond changes to form fructose 6-phosphate right there. Another ATP invests a phosphate group. The glucose gets lysed into 2 3-carbon chains. Let's just ignore one of them for now. It'll just overcomplicate things. They both go through a nearly identical set of processes. Now it gets more complicated. An NAD plus gets reduced to NADH, attaching another phosphate group to the chain. A phosphate group from the carbon chain is attached to an ADP molecule, forming ATP. The remaining phosphate group is moved and then is bonded to an ATP molecule. The remaining 3-carbon chain is changed to a 2-carbon chain, and then bonds with oxaloacetic acid to form citric acid. The citric acid gets oxidized in the Krebs cycle to form more oxaloacetic acid and a whole bunch of NAD+, represented by the hydrogen molecule suddenly disappearing. We're now in the mitochondria, where the majority of the ATP is produced. All that NAD+ gets put to use now. A hydrogen atom and 2 electrons are transferred to coenzyme Q, and then to cytochrome C, and afterwards bound with oxygen to create water. All the energy released from the electrons going from a high energy state to a low energy state is used to pump protons out of the center of the mitochondria. The change in the charge gradient causes the protons to enter the center of the mitochondria. That energy is then used to create more ATP.